Hello, good morning, engineer. Today I come to present the topic of the effect of McCont's breakup on the risk analysis and risk management. McCont 1 is an oil field prospect located in Mississippi Canyon Block 252 of the Gulf of Mexico, approximately 69 kilometers southeast from the nearest shorelines in Louisiana. The prospect was purchased by British Petroleum for the mineral right to drill for oil in the Minerals Management Service lease sale in March 2008. The prospect may have held 50 million barrels productive reserve of oil. Transocean on October 7th, 2009, the Transocean Marianas semi-submersible rig commenced drilling, but operations were halted November 29, 2020. On October 7th, 2009, the Transocean Marianas semi-submersible rig commenced drilling, but operations were halted November 29, 2009 at 4,023 feet below the sea floor when the rig was damaged by Hurricane Ida. The Transocean Water Horizon rig resumed drilling operation in February 2010. On April 20, 2020, on April 20, 2010, the fall of well integrity followed by the inductor influx and the ignition of hydrocarbons caused a broad and catastrophic explosion on the accident, the contributing factor as well as risks associated to the blowout. The current study report has found necessary to review the surface characterization and geohazard analysis in addition to other complex relationships such as well design, human and organizational factors that made the McCont disaster to happen. Based on an existing investigation reported, PP Investigation Team, September 9, 2010, Chief Concert. The following section systematically reviews barriers, performance, and reasons that have caused the error defection during McCont well completion. It also prevents in brief the design, engineer, logistics, and operational challenge related to Macondo. Macondo, the prospect name given by BP after the fictional town in Gabriel Garcia Marquez' 1970 novel, 100 Years of Solace. A review of risk analysis and management study related to McCont blowout. Nearly 3 years have passed since the McCont blowout. The accident happened April 20, 2010, due to the loss of well control as all the systems barriers fall to counter the hydrocarbon kick, the entry of high pressure, high temperature, high charger hydrocarbons out from the Macon exploration well to the right, and its subsequent ignition caused a blowout and catastrophic explosion. The accident killed 11 and severely injured 17 platform crew workers. A severe fire fed by the hydrocarbons from the well continued for 36 hours and caused the modem sank. For almost 3 months, a large offshore oil spill followed, caused a huge environment sediment in the Gulf of Mexico. Extensive investigation, studies, and research followed this accident in the response to USA President Directive. The Salazar Report on May 27, 2010 conveyed an exhaustive review of the Macon event and report and precautions and technology that should be required to improve the safety of oil and gas exploration and production operations on the other continental shelf. The report underlines the drilling activities in the Deepwater environment create increased risks and challenge, and there is a need to re-evaluate whether the best practice for safe drilling operation development over the years need to be bolstered to account for the unique challenge of drilling in deep water. The Salazar report highlights immediate as well as short-term actions to enhance the safety of future OCA's drilling activities. Thus, recommend cover specifically the following categorization. Number 1. Blowout prevent equipment and emergency system. Number 2. Producer and ensure healthcare physical barriers and well-controlled systems are in place to prevent oil and gas from escape into the environment. Number 3. Organization and safety management. The BP and the Transocean Investigation Report carried the fact sorting the accident, analyzed environment information to identify possible cause, and made recommendations to enable prevention of similar accidents in the future. The BP accident investigation team used fault tree analysis, define and consider various scenarios, false modes, and possible outcomes. Based on analyzed information, the team found that the accident was due to accomplish an interlinked series of mechanical failures, human judgments, engineers design, operations, implementations, and team interface in a circumstance of multiple companies and work teams involved over time. The Transocean Investigation Report, through an extensive interview of witnesses, the review of variable information regarding well design and exhaustion, as well as the examination of real-time well monitoring data, that found that the Macon accident was the result of a succession of internalized well design, constructs and temporary abandonment. Decisions that compromise the integrity of well and compounds the risk of it failure. At Macondo, the window for shape drilling between the fracture gradient and the pore pressure gradient become increasingly narrow, and to maintain the appropriate equivalent circulating design, ACD become difficult, and this was experienced through severe kicks and loss of fluid to the formation during the drill operation. Many independent reports focus mainly on root cause, other analysis results from investigation reports and or the reevaluated various performance to document the failures of Deepwater Horizon. Barrier is defined as measure with reduce the probability of release hazard potential for harm and which reduce its consequence. Maybe passive or active physical, technical, or human operation systems. For the case of Macon's accident, barriers cover complex causal relationships such as human factors, the file surface characterizations, and technology used during drilling operation. In May 7, 2010, the PSA established a project team to systematize and assess experiments from Macon accident and thus from the learning draw recommendations that can contribute to the improvement of safety and emergency preparedness in relation to drilling and well operation to the NCS. Based on produce investigation reported as well as on a number of assessments by various professional bodies and various national and international processes. The PSA team found that the accident underlying causes were the same as those identified for the Montara blowout happened uh, 8 months early in shallow water of the Time Sea. According to PSI, the Deepwater Horizon accident must be seen as a wake-up call to the Norway petroleum sector that is must lead to a big improvement in management major accident risks, and that the concludes that the safety culture needs developing throughout the industry must also be considered relevant for Norway petroleum activity. Among other requirements of high priority, the PSI report suggests the improvement in the various management and to improve the well integrity problems. More than 30 working papers by THSG highlight lesson learning from Macon Fowler. The paper's finding records that oil and gas exploration and production has embarked in extreme environment such as in the ultra-deep waters and in the Arctic that resource deployment will require new strategies to reduce the future line of major failures such as in control, blowout, production, operation, explosion, and fires. Several scientific papers, literature studies, draw textbooks, and publications were made with expectations that lessons learned from Macon blowout bring new emphasis on practical risk analysis and risk management in the industry. Some focus on quality risk analysis, while others use quantity risk analysis. Quality risk analysis use the new lens on risks from the expert drug in discuss to present a simplified risk picture on the described category of course scale. Drug quality risk analysis and the use of tools such Revit flow diagrams found five critical components in both that give the through quality risk analysis and the use of tools such as reliability blocks diagram. FMECA form five critical components in above that give the highest bowl of safety performance starting from number one, shooter valve, blind shear ram function. Number two, blind shear ram piston. Number three, flag boops stack. Number four, gasket boop stack. And number five, annual preventer rubber hose, respectively. Thus the shuttle valve for high reserve ram function and the blind shear ram are the most critical component in the bob. The quantity risk analysis, also known as probability risk assessment, probabilistic safety assessment, concept safe evaluation, and total risk analysis, use the knowledge of risk from model-based risk such as event tree analysis, fault tree analysis, and other tools to represent the risk picture. Quantitative risk analysis studies show that a logic element tree model based on fault tree and cause-consequence diagrams may provide an endeavour model proceed on an overall level in the blowout model. Fault trees typically give a static picture of the subject for analysis whilst CCTS allow a proper model of the dynamic condition. These modeling tools contribute to visualization the cause and event sequence risk aspects. Sensors lead to kick and blowout and thus continuous substrate means for communication. Risk aspect regarding kick and blowout to drilling and safety personnel. A computer model blow farm coupled to handle uh, A computer model from compared to highly three how three how a computer model blow form coupled to handle 300 risk element and choose practice. Blow risk for a gives seat is a described in today blow farm. Development focus on the risks contribute and called tubing and sugar and incorporation of issues like underbalance drilling. Flow farm was development using system of short blowout state. According to this date bus risks due to unexpected overpush, narrow pressure marine contribute to 60%. The contribution from Operation Haspen is circa 8 ports, while issues related to rig, riser, and well amounts to 32 portsmen. Low fan model has shown possible achievement compared to traditional kick. Frequency and Bob relatively approach sucks the quick detection and the surface measure be mean of the flow at the rig floor. Understand risks associated with deep water drilling and completion. The case of Macon fail. In very recent days, the petroleum world wishes become focused on submerging and the exploration of new oil and gas reserves located in complex extreme environments such as Deepwater, oil sands, shale plays, and the Arctic. For the case of the Deepwater, four major deepwater basins are identified in the world. Use 1.5 million, Brazil 1.7 million, Angola 1.4 million, and Nigeria 1.2 million, along with other missile nodes passing at 0.7 million. Such, such reservoirs are more complex, more technology intensive, and they constitute a challenge to the current risks and risk management practice. The experience with the PP Macon oil spill illustrates a noteworthy task in the content of blowout in deep water. Surface characterization and Hogarth's analysis. The key object of a city survey is to geohazards and to enable the risks posed to drilling operation by, by the seabed and geological conditions to be management and reduced. According to its characters, mainly be extremely high rate of sediments and burial, having predominantly very young neogen 30 reservoir with expansion of the few insulated unaffected. B uplift and erosion occurrence such as certain reservoirs in the Perdido Fault Belt in the Gulf of Mexico and the area of Macondo Prospect. The Gulf zone across the basin is controlled mainly by the geothermal gradients and the sedimentary burial from the Mississippi River system. The Golden Zone is a concept used by location based on geothermal gradients. The basal zone, which is bounded by the 200 grados Celsius and 120 grados Celsius isotherms, is where most hydrocarbons and generate from source rocks. The zone is therefore named the expulsion zone and is characterized by low permanent and high pore pressure capable of hydraulic fracture the rock. Here only a minor percent of the oil and gas is trapped with a grand static environment show that the highest volume concentration of hydrocarbons corresponds to the 90 grado zero isotherm. Analysts come dated by show that despite the extreme rates of porosity loss in the company zone, the median, the pressure reservoir pressure probability is for natural or near hydrostatic pressure to occur at temperature menor que 60 grados Celsius, at temperatures mayor que 60 grados Celsius, the probability of overpressure begins first to increase greatly and later at temperature mayor que 120 grados Celsius, the increase exponentially. Here, subs improvement condition reflects reservoir of high pressure, high temperature. HPHT. The high pressure and high temperature are defined as those with temperature mayor que 120 and mayor que 1.4 times hydrostatic pressure gradients, or mayor que 1.4 grams sobre centímetro cúbico specific gravity gradient, or about mayor que 12 pounds per gallon drilling mode weight. According to Paul H. Nadium, those HP and HT drilling conditions are more rigorous in the figure of overpass risks rather than the mayor que 1.7 grams sobre centímetro cúbico or 15 pounds for gallon drilling mud weight and mayor que 149 Celsius values currently used the petroleum industries. That overfunding are the increments with the paper of close at the 2008, which indicates that the area of GOM has a unique combination risk influence factor compared and to Deepwater wells in other parts of the world, and the same perp points of the in water depths of the over 3,000 meters shoots in pressure and more than 690 bars. Bottom hole temperatures are higher than 195 Celsius. It also is oversmed problematic formation with salt zones and tar zones. At Macon Prospect, the total depth was reached at 80,360 feet, or 5,596 meters. Reservoir sands contain hydrocarbons and pressure approximately 11,850 psi, or 817 bars transocean. In other words, deep reservoir located in more than 90,000 meters through vertical deep and 5 sandstone reservoirs menor que 10 millidarcy display extreme flow assure ensures. I've shown the Chi-zeta concept present a predictive power with respect to its ability to quantify exploration risks, particularly for overpressure development and for high pressure and high temperature development. Understand the geologic process responsible for the occurrence of high pressure and high temperature reservoirs in vital in order to properly assess these risks as well increase explorer efficiency. Paul H. Nadius has demonstrated that 79 poles are about 4 out of 5 Chi-zeta reservoirs are NPNT as compared to 64% high pressure, high temperature, or about 2 of the 3 reservoirs in the expulsion zone. This means that the risk of high pressure reservoirs increased by a factor of 3, or 3,000 pounds, and temperature mayor que 120 Celsius. In order to improve safety and lower environment risks both for exploration and production drilling operation, it is a stress in admins to use geothermal gradients. Drilling technique and well design. Research has revealed that drilling in deep water is complex. The drilling window is narrow. The narrower the window, the more difficult to execute drilling operation. In this situation, the industry needs to hazard risks and monitor well operation in a life cycle. Deepwater reservoirs have generally such narrow drilling windows between the pore pressure and the fraction gradient. Resolving one problem of their creates other and the well control becomes determined. Show that the moment the previous choice is a drilling out is AC is too high to drill a single foot of formation. Drilling technique for narrow windows. The drilling work for narrow windows involves two factors: the equivalent surface density as well as the equivalent circle density. The chief concern deficit ACD as the pressure extension by a column of fluid in the buffer in static condition, while ACD refers to the total pressure that the same fluid column exerts when it is circulating. When circulating, ACT exceeds AST because the force required to circulate the fluids exert additional pressure on the well bore. The impulse loss and still the overpressure expressed by the mud is too small to hold back formation contents and the kick in the result. Sucks and well takes in consideration will the use management drilling. Equipment to remove the ACD effect. Well teasing. According to Practical and Lacey, the drilling industry needs to record where serious risks exist in complex well development and to sign wells which the uncertainties in geology risk. They claim that in some categories of complex wells, wellbore stability events are as high as 10 parts of the total deepwater well time, and well control incident over 4 times those for normal wells. Basically, the well design must ensure that the drilling fluids and casing string works together to balance and contain pore pressure in the rock formation without fracturing the rock. For deep water conditions, well designed, special attention is paid to the annular pressure. For this occurs when the high pressure hydrocarbons travel up on head of the well. In some cases, the pressure can become high enough to collapse casing strain. A number of these features to manage annular pressure or mitigate the risk of casing collapse exist. These include rupture keys, compressed fluids, and annular space, and insulate production tubing. In the original plan for the Macondo well, PP specified the use of a long string casing of their experiencing loss circulation problems between the section 17,168 and 18,360 feet. PP considered use the aligner to minimize to downhole pressure expert during installing an 70 industry that in Mississippi Canyon Block 252 area indicated that approximately 57 of the well use long string while approximately 36 ports use liner or liner with tieback. During temporal abandonment, the top of the long string ball be sailed at the casing hanger in the wellhead for later production, while the liner would be sailed at the downhole liner hanger with the striation of a tieback at a later date before production start. Unit the Macon Accent, the Board of Ocean Energy Management Regulation of Government, formerly the Minerals Management Service, was the United States Department of the Interior Institute responsible for leasing safe government compliance and royal collection and other continent self. Following the report presented by the National Commission of the PP Deepwater Horizon oil spill and the offshore drilling, September 14, 2011, the bomber pressure additional same regulation that authorized una nosed right inspection and 30-party audits as part of a major organization wide split in 3 institutions. And recommended in the May 27, 2010 report from the Secretary of the Interior to the U.S. President Barack Obama, U.S. Department of the Interior, a new regulation identifier number ring under the ring.